Good afternoon. Last week you studied overview of statistics, and what is the next session? Types of data and the levels of measure. Okay, then today I'm going to start session number 3, presentation of the categorical data. Okay, you studied now, then types of data. Okay, then the first category is, what are they? Quantitative and the qualitative. Okay, then data can be measured as numerically, we called as quantitative. Okay, then data or variables cannot be measured as numerically, we called as qualitative variables. Okay, then quantitative variables can be divided to the further. What are the two kinds of quantitative data? Discrete and the continuous. Okay, then discrete means what? There are certain specific values. Okay, continuous means continuous means there is a gradation between two values of measurements. Okay, then examples of the discrete random variables, the marks, not the marks, number of students in a class. Okay, the number of students in a class, we can say 40, 50, 20. Okay, there is a specific value. Continuous means gradation between two values of the measurements. What are they? Weight, height. Okay, there is no any. Always we cannot write the specific value to the continuous variables. Okay, then today's session is we move to discuss presentation of the categorical data. Okay, chapter 3. Then these are the learning objectives. Okay, to introduce the how to tabulate the categorical data and interpret results, methods of diagrammatic and graphical representation of the categorical data. Okay. Then these are the learning outcomes. Okay. Then first we move into the tabulation. Before moving to the tabulation, the second lesson we studied, there are two types of data, primary and the secondary data. Okay, and we discussed how to collect the primary data. Okay, then using the questionnaire method, okay, we can conduct the interviews to collect the data, and we can do the direct observations. Okay, then the collected data in any statistical investigation be known as what? Raw data. Okay, then first we conduct any survey, okay, to collect the data, then we called as raw data. Okay, then usually when data is collecting, there is a lot of numbers, okay, facts, symbols, those things. Okay, then they cannot be easily understood by the person. Why? There is a lot of numbers, words, those things. Okay, then before do the analysis, then the first thing is what? Need to summarize those raw data. Okay, then first time we collect the data, then we call as raw data. Okay, normally raw data cannot be understood easily by the person. Okay, then we cannot conduct the further analysis using the raw data. Okay, then in the fact there is usually so much data, it needs to be summarized it. Okay, we do the summarization, that raw data. Understood? Okay, then Then after having the collected and edited data, what is the next step? Next step is present the data in the systematic manner. Okay, now we have the lot of data. Okay, then we will present those raw data in the systematic manner. Okay, then what is the first way we can present the data in systematic manner? Tabulation. Okay, tabulation means what? All of you know what is the tabulation? Present the data using the tables. Okay, did you know about the tables? No? Okay, then the tables. Okay, then we have the raw data. Then we can summarize those raw data using the tabular format. Tables. Okay, then what is the meaning of the tabulation? Tabulation means the systematic presentation. Okay, then systematic presentation of the numerical data in the columns and the rows. Okay, normally you know the table. No? In the table, there are columns and the rows. Okay, then using the tables, using the tabulation format, we can present the data in systematic manner. Okay, normally in the tabular format, we present which kind of data? Numerical data. Okay, numerical means what? Quantitative data. Understood? Clear? Okay. Then these are the main objectives of the tabulation. Okay. Objective means why we need to use tabulation format to present the data. Okay, then what are the objectives? First one is to summarize the categorical data. Okay, summarize. Using the tabular format, we can summarize the data. Okay, think we have a lot of numbers. Okay, then we collect the data. Then we have lot of numbers or words, those things. Okay, in the tabular format, we can present using the only we can present the numerical data through the tabulation format. We can summarize it using the tabular format. Understood? Okay, then other one is we can simplify the complex data. Okay, then we have the lot of numbers. Okay, we cannot get any idea about that data set. No. Okay, then but we use the tabular format and present those data. We can get easily understood what they represent. Okay, then using the tabular format, we can simplify the complex data. Clear? Okay, then to facilitate the comparison. Using the tables, we can do the comparison. We can compare. Okay, then this is the example. Then this table represent the level of education. Okay, the level of education is a qualitative variable. Okay, then the level of education, then we can categorize it. Okay, then it is the categorical data. Levels of education, O level, A level, graduate, and the postgraduate. Okay, then first column represent the frequency value. Okay, then we can compare. Okay, then how many respondents complete the O level? How many of the respondents completed the A level? Okay, then we can take the frequency value and we can compare. Okay, then using the tabular format, we can comparison. The next one is to find the associations between variables. What is the meaning of the association? Association. Give me the simple word for the association. We can find out the relationship between two variables. Association means what? Relationship. We can identify. Okay. Then to facilitate the statistical inference. Okay, normally in the book, magazine, report. Okay, then we insert the tables. No, why we insert the table? Why we insert the tables? To reference. Okay, insert the table and we write the reference number or something. No? Okay, insert the in the table of content, we insert the figures, those things. No? Okay, then we can insert the tables in the reports or the research or book, magazine, those things. Okay, then we using the tabulation. Okay, then we clarify the characteristic of data. Okay, then through this table format, we identify that the first we write the what kind of categorical variable represent through this table. Okay, then inside the table, what are they include? What are the categories in corresponding categorical variables? Okay, then to detect the errors and omissions in the data. Okay, then normally we write the paragraph, okay, using the raw data. Then sometime can be repeated, same one. Okay, sometimes can be happen repeated, but using the tabular format can be repeated. Okay, then one type of data represent only one time. Okay, then this is the advantage of the using the tabular format. Okay, now you know what is the table. Table means systematic presentation of the numerical data in the columns and the rows. Okay, then these are the objectives why we need to tabulation. Understood? Clear? Okay. Then we move into the next one that we call as the frequency table. Okay, normally we draw the frequency table. Okay, in the frequency table is a list the categories in one column and the amount of frequency in the different columns. Normally in the table there are columns and the rows. Okay, then the first column always represent what? Categories. Okay, then before you saw the tables, no? Then this is the frequency table. Then first column represent the categories of the variable. What are they? O level, A level, graduate, and the postgraduate. Okay, then the other columns represent the frequency value. Okay, frequency means what? It does mean the first one is O level, then the frequency value means 8. It means 8 respondents are completed O level. Okay. Then are often presented as list ordered by quantity, showing the number of times each category or value varies. Okay, frequency means what? Number of times each category. Okay, then that we call as frequency table. Okay, clear? Okay. Then these are the examples of the frequency table. Okay, then normally we use the frequency table that we represent only one categorical variable. Okay, then first column represent the variable categories, the other column represent the frequency value. In here, first column represent the frequency, number of times occurs in each category. The second one represent what? Percentage value. Okay, then those frequency value we can convert it into the percentage value. Okay, then we take the total in here 95. Okay, then first category, the frequency value is 8. How to convert it into the percentage value? 8 divided by 95 into 100. Okay, then it means 8.4% of respondents who were studied up to O level. Understood? Okay, then the 33.7 in the A-level category. It does mean 33.7% of the total respondents who studied up to A-level. Understood? Okay. Then this one is we call as the valid percentage. It means some we conduct the survey, some data may be missed. Okay, then there are some missing values. Okay, then we consider the missing value and we calculate the percentage value that we called as the valid percentage. Okay. In the other one is cumulative percentage value. Okay, then first one is okay, then the same. First category percentage value is 8.4. Cumulative one is also 8.4. But in the second one, 33.7 is a percentage value, but the cumulative one is 42.1. Okay, how to calculate the cumulative values? We add to the previous one. Okay, then the first one is 8.4. Then we add to the second percentage value, 33.7. Then what is the cumulative one? 42.1. Okay, then the 42.1 represent what? It means 42.1% of the total respondents who were studied up to O-level and the A-level. Okay, then first two, both categories represent through this 42.1. Total values is there, no? Cumulative value. Understood? In the 76.8 is the cumulative value, percentage value. It just means what? 76.8% of the total respondents who studied O-level, A-level and the summer graduates. Understood? Cumulative percentage value. Okay, and then we want to take the tables. Okay, then using the SPSS software, then this is the output. Okay, then we feed the data. Okay, then to the weave, then we convert it into the table. No? Normally we can do the analysis of the descriptive part. Then they represent the table. Then this is the output. Normally it represents the categories, frequency value, percentage value, and the cumulative percentage value. Understood? Then this is the output from the SPA. Okay, and then normally today's world do all the statistical analysis using the software. Okay, then we can use the SPSS or MATLAB. Okay, then we can use the Python. Okay, different kind of software we can use to do the analysis. Okay, then there is a next table. Then what is the variable? In the second table, variety of antics. Okay, then it's the one kind of qualitative data. Qualitative, no? Okay, then then there are what are the categories? Furniture and the brass. Okay, then these are the categories. Then next column represent the frequency value, percentage value, valid percentage value, and the cumulative percentage value. Understood? In here, they represent the missing value, no? In the system, missing the 5. Okay, then this 5 data are missing. Understood? Okay, then this the format is the frequency table. Okay, clear? Now clear what is the tabulation format and what is the frequency table? Okay. Then we move into the next one. Okay, then before you study the simple way of frequency table. Okay, using the frequency table, only we can present one categorical variable. Okay, then these are the two examples. Represent only one categorical variable. First one represent the level of education. Second one represent the variety of antics. Only one categorical variable. Okay, then move into the cross tabulation. Using the cross tabulation, another word we can say contingency table. Okay, cross tabulation, or we can say contingency table that display the relationship between two or more categorical variables. Okay, think if you want to represent the two or more categorical variable, we cannot use the simple frequency table. Okay, then we move into the cross tabulation or contingency table. Okay, then using the cross tabulation or the contingency table, we can represent the two or more categorical variables. Okay, it means nominal or ordinal levels variables. Now you know the levels of measurements. Okay, nominal, ordinal, interval ratio. Okay, in the normally qualitative type of data, their levels of measurement is nominal and the ordinal. Okay, the nominal measurements only we can take the count of each categories. Okay, only we can label it. Then ordinal one we can order them. Okay. Then this is the example of the cross tabulation. We call as two-way table. The first one, two-way table. Okay. Then two-way table means in this cross tabulation, how many categorical variables are represented? In this example, 2. Okay. What are the two categorical variables in here? Level of education and gender. Okay. Therefore, we call as what? Two-way table. Okay. If you need to represent only two categorical variables, we can use what? Two-way tables. Understood? Okay. Then moving to how to read the two-way table. Okay, this is the important thing now. Okay. Then the first one is the 5. This 5. How to read this 5? This number, what does represent? 5 male respondents who were studied up to O level. Okay, then we compare, then we use the two categorical variables. In here, this 22, then we can say 22 graduates are female. Okay, then we can interpret anyway in the two-way table. Okay, normally if we need to represent the two categorical variables, we move into the two-way table. Okay, then important thing is how to read it. Okay, how to write the analysis in using the tables. That's the important thing now. Okay, in the today's world, then we using the statistical software and we can get the table. Okay, then we need to know the path, how to take the contingency table or how to get the frequency table. Okay, then the software generate the table. Okay, then we have the output. The important thing is how to interpret. Okay, how to write the interpretation, those out. Okay, it's a very important thing. Okay, no need to develop the tables. No need to study how to draw the tables, those things. Okay, then the important thing is how to interpret it. Okay, then if you need to write the report, normally we insert the table. Okay, then the important thing is your interpretation. Okay, based on that, you can get the mark. Okay, understood? That's clear how to interpret the two-way table. Okay. Then we move into the another one. In here, how many variables are there? In here, how many variables are there? Gender, level of education, language, house or not. Okay, then how many categorical variables are there? 3. Okay, then that we call as what? Three-way table. Okay, then it represents gender, level of education, and land with house or not. Okay, they own the house or they do not own house. Okay, then we move into how to interpret the three-way table data. Then move into this one. This value 7. Okay, then this represent the frequency value now. Then the 7. Then how to interpret this number 7? How to interpret? 7 male graduates. Then the land with house is yes, no? Okay, then how to interpret? 7 male graduates who own land with house. Okay, then we write the interpretation. It includes all the three categories, three categorical variables. Okay, then we can say, then the six female respondents, okay, who studied up to A level and they own land with house. Okay, then this is the way we write the interpretation using the three-way table. Understood? Clear? Okay, then we move into the another one. Okay, then this is also the cross tabulation. Okay, then how many categorical variables are there? How many categorical variables are there? Gender and the marital status. How many? 2. Okay, then it's a completed table. Okay, that represents the count. It means frequency value. Okay, and the percentage value also. Okay, then how to interpret that kind of cross tabulation? The first one, then this column, male. Okay, gender is the male. Then this column represents the male respondents details. Okay, then 21. But what does mean the 21? 21 respondents are single male respondents. Okay, then that's 47. It does mean what? 47 respondents are male and they are married. Understood? That is the way we can take. Then normally we in the table normally we insert the total values. Okay, row total and the column total, and other one is grand total. Okay, in here then this one is the grand total 200. Okay, then this one is 51 means what? 51 in here. What does mean 51? Total number of single respondents. Okay, then 137. Total number of married persons. Clear? Okay, then in here, what does mean in the 71? Total number of male respondents. Okay, then these totals give the row total, then these total gives the column total. Okay, clear? Okay, then we move into these things. Then first percentage value, it means within marital status. Okay, within marital status. Then how to calculate this percentage value? Okay, then there are 21 male here. Okay, then those 21 male respondents are single. Okay, Then the 41.2%, how to calculate? Within marital status, no? Okay, then first take the total number of single respondents. How many? 51. Okay, then how many of them are male? 21. Within marital status. Then 21 over 51 into 100. That is equal to 41.2%. Understood? Okay. Then the next one, within gender. Okay. Then first we take the total number of male respondents. How many? 71. Then the 21 over 71 into 100. Within gender. Okay, then first consider about the how many total male respondents are there. Okay, then take that value and we calculate the percentage value. Within marital status, then first give the priority to the marital status. Understood? Okay, then it means 41.2%. Okay, how to interpret that value? 41.2%, how to interpret it? How to interpret it? 41.2%. 41.2% of single respondents are male. Why? Within marital state. Okay, then we calculate the 41.2% based on the total number of single respondents. Okay, then 41.2% represent what? 41.2% of single respondents are male. Understood? How to interpret the 29.6%? This one, it gives within gender. 29.6% of the male respondents are single. Understood? Okay. Then 10.5% means what? It gives total. 10.1. How to get it? It represents how? 10.5% of the 10.5. Then first identify how to take that value. Okay, using the calculator and hurry up. 10.5. Total number is 200, no? Okay. Then how many of them are single and male? 21. Okay, then 21 over 200 is 10.5%. Understood? Okay. Then in here 15%. 200 is the total one. In this one represent the 30. Then 30 over 200 into 100. Understood? Okay, clear? Okay, then we can say then the majority, then the first one represent the majority of married employees are female. Is it true? Majority of the married employees are female. Then the married, this column, no? Sorry, the second row represent the married. Okay, then the male 47, female 90. Okay, it is true, no? Then majority of the married employees are female. The second one says majority of female employees are married. Then we move into the female column. Okay, then highest number of representing the merit category. Okay. The majority of the female employees are merit. Okay. The second one, they have no widowed male employees in the sample. Then widowed category, 0 in here. There's no any respondent. Then the only 6% of the employees are widowed or divorced. Then, okay, then this is the way we can interpret the cross tabulation. Okay, then first we want to read these words first. Based on that, we can write the interpretation. These are very important. Then this the percentage value. Then we look in at what? Within marital status. Then first give the priority to the marital status. That's 29.6%. This one shows within gender. Okay, then first give priority to the gender. Understood? Okay. Then we move into the diagrammatic presentation. Okay. Do you know about the diagrams? Yes, no? Okay. You know different kinds of diagrams. Okay. Then diagram means what? Then when we need to represent the data, then we can use the tabular form. Okay. Then another one is we can use the diagrams. Then diagram means what? Visual form of presentation of the statistic data. That is a visual formation. Okay, that's a picture. No? Normally diagram means there's a picture. No? Okay, then that is the visual form of presentation of the statistical data. That we called as diagram. Okay. Then the diagram refers to the various types of devices. What are they? We can use bars, we can use the circles, okay, we can use the map, okay, then we can use the pictures, those things. Okay, then these are the types of diagram. Okay, what are the types of diagram? Simple bar diagram, multiple bar diagram, subdivided bar diagrams, percentage subdivided bar diagram, pie diagram, those things. These are the diagrams. Okay, in the descriptive statistic part, okay, then when we need to do the descriptive analysis, we use the diagrams. Okay, then in this, you know what is the statistic and the two types of statistic now. In the descriptive part, we collect the data, we can organize, okay, then we can present the data using the different format. Okay, in your research, then in the final year research, then you need to do the analysis part. Normally in the research, then first we do the descriptive analysis part. Okay, in the descriptive analysis part, we need these kind of diagrams to represent your data set. Okay, understood? That's the visual form of presentation of the statistical data. Okay. Then first one is what? You know, simple bar diagram. Okay. Then what does mean? Simple bar diagram can be drawn either horizontal or vertical way. Then this one is horizontal or vertical. Vertical. Horizontal means this way. Okay, then this is the vertical way. Okay, in this simple bar diagram, only we can represent the one categorical variable. A simple bar diagram. Okay, then using the simple bar diagram, we can represent only one categorical variable. In here, what is the categorical variable? Level of education. Understood? Okay. Then what are the categories? O level, A level, graduate and postgraduate. Okay. In the simple bar diagram, there are two axes. Okay. This is the vertical way. No? Then this axis. X-axis represent what? Categories of the variable. The next one, Then normally we say the y-axis, no? Then this axis represent the frequency of the each category. Okay, then normally we use in the diagrammatic way to present the data, then person can be easily understood. Okay, that's a visual form, no? Okay, then people can be easily understand. Okay. Then this is the other way, simple bar diagram in the horizontal basis. Okay, then this one is, this axis represent categories and this one shows the frequency value. Okay. Then we move into the another one, multiple bar diagram. Okay, then the other name is compound bar diagram. Okay, both eyes. Okay, multiple bar diagram or compound bar diagram. Then this one used to denote more than one phenomenon. Okay, then we can use the multiple bar diagram represent the two or more phenomena. Okay, then this represent level of education and the gender. Two categorical variable in here. Okay, then in here and the two bars. Okay, then first bar represent the male, another one female. Okay, then this one is O-level category, this one is the A-level category, this one is the graduate, and this one is postgraduate. Okay, in the using the multiple bar diagram, we can do the direct comparison between the two values. We can do the direct comparison between two values. Okay, in here, then the first one is in the O-level category, 5 are male, then the 3 are female. Okay, in the O-level category, most of them are male. Okay, we can write it now. Okay, then in the A-level category, most of them are female. Okay, then using the multiple bar diagram, we can do the direct comparison between the two values. Okay, understood? Then we move into the another one. Subdivided bar diagram, or we can say component bar diagram. This one is multiple bar diagram or compound bar diagram. Okay, then this one subdivided or component bar diagram. Two words, okay, in the multiple bar diagram we known as compound. This one we call as component. Okay, in the subdivided bar diagram, then what happened? There is a bar. Okay, then this called as bars, no? Then these bars is subdivided into the various parts in the proportion to the values given in the data set. Okay, then the first one is O-level category. Then this bar shows the O-level category. Okay, then this bar is subdivided into the according to the gender. Okay, then the height of this bar represent the total number of O-level respondents. Okay, it means total number of respondents who were studied up to O-level. That is represent the height. Okay, then this total value we divided into these two kind of categories, gender and the, male and the female. Understood? Okay. Then move into the another one, the same subdivided bar diagram, but percentage subdivided bar diagram. Okay, then what is the special thing in that one? That is the subdivided bar diagram. This one is percentage bar diagram. There's a special feature in here. What is that? The bars are all equal height. Okay, then height of each bars are same, no? Why? What is the reason for that? What is the reason for that? Each bars represent the total percentage value. Okay, normally total percentage value is always 100. Okay, then the height of each bars represent the 100%. Okay, then the first one in the O-level category, there is a total value is think 8, then 8, 5 are male, 3 are female. Okay, then both value we can convert it into the percentage value. Okay, then 5 are male, then the 5 are male, then 5 over 8 into 100. Okay, then first, then when we want to draw the percentage subdivided bar diagram, then first draw all the bars are in same height. Okay, then we divided into the two categories. Okay, then the first one represent the male, no? Okay, then in the first one, then 5 are male out of 8 respondents. Then the 5 over 8 into 100. Then it represents first. Then remaining part shows female respondents who were studied up to O-level. Understood? In the percentage subdivided bar diagram, normally we do the comparison is made on the relative basis. There is a percentage value now. Okay, normally we do the comparison based on the relative basis. Understood? Okay, the various components are expressed as the percentage to the total value. Okay, then we always calculate the percentage value based on the total value. Understood? Okay. The next one is what? Bar diagram. Or, sorry, not the bar diagram, pie diagram. Okay, we can say pie chart. Okay, then the pie chart is the simple descriptive display of the data that the sum to a given total. Okay, then the format is of circle. Okay, normally pie chart, then when we need to represent the data using the pie chart, normally we draw the circle. Okay, the pie chart is probably the most illustrated way of displaying the quantities of the percentage of the given total. Okay, then when we need to draw the pie chart, we use the degree value. Degrees now. Okay, then total degree value in the circle is 360. Okay, then we take the frequency of each category, then that frequency value we converted into the degree value. Okay, then based on that, we can draw the pie diagram, pie chart. Okay, but we display only the percentage value. Okay, normally we do not display the degree value. Okay, in here there is a male and female. Nothing female percentage value is 200 degree. Okay, normally we do not display the 200 degree. Okay, then we display the percentage value. Okay, then we use the degree value to draw the pie chart. Okay, but we display the percentage of each category. Understood? Okay, that is the systematic way how to represent the pie chart. Understood? Okay. Then the other one is then the we need to draw the pie chart. Okay, then there are too many slices in the pie. Okay, then there are so many categories in the one variable. Okay, that is the not best way to represent those data in using the pie chart. Okay, then we have the 3 or 5 categories. Okay, no problem. We can use the pie chart. Okay. Then other one is when we move into the graphical representation. Then simple bar diagram, multiple bar diagram, subdivided bar diagram, pie diagram. These are the diagrammatic way. Okay, then these are the visual form of representation using the diagram. Then these we called as what? Graph. Okay, graphical representation. Okay, then the graph is the visual presentation of the data set. It enables to present the data in the simple, clear, and the effective manner. Okay, then we using the graph, we can interpret, we can present our data in the very clear form. Okay, we can take the example is the line graph. Okay, line graph. Then normally we use the line graph. Then we have the data set. Those data changes according to their time schedule. Okay, then we use what? Line graph to represent the data set. Okay, in here, then this one shows identify that there was an increase in CR from year 2001 to 2005. Okay, then after that there was a decrement between year 2006 to 2009. Okay, then those data relating with the time. Okay, normally we have the time series data. We use what? Line graph to represent those kind of data set. Understood? Okay. Then okay. Okay, other one is using the line graph only we can be present one variable. Okay, normally we use the only one variable is to represent the graphically we can use the line graph. Okay, then other one is what kind of data we can use to draw the line graph? What kind of data? The value of the variables changes over time period. Okay, normally we do the time series analysis, we can use the line graph. Okay. Then we move into the important thing. Okay, normally we do the graphical or diagrammatic presentation. Okay, these are the things we consider about the important things. First one is must have a title. Okay, then we take the output of the diagram. Okay, then we insert, then that we diagram we insert to our report. Then first you write down the what? Title of the diagram or the graph. It is must. Okay, what it does represent. Okay, then must have a title. In here, this one shows figure 1 bar part of the group of the audience size. Then first you must write the title of the bar diagram. Okay, or any line graph or pie chart. Okay, the title is the must. Then other one is then there are two axes. Okay, we want to label the two axes. Okay, then x-axis what represent, y-axis what is the represent. Okay, then the x-axis represent the in here team, then we write it. Okay, then the y-axis represent the marks, label it. Okay. Then other one is in the line graph there are several variables. Then we use the colors or pattern. Okay, then we want to identify the each variables differently. No? Okay, then we use in the different colors or patterns to describe these kind of variables. Then other one is label axis. Then other one is then we draw the graph or diagram. The lettering must be horizontal way. Then always we write the letters in this way. Okay, we do not write the word in the vertical way. It means we cannot write word, one letter one, then the thing, first one is the bring labels, then BRING. In the vertical way, we cannot. Okay, then always all the lettering must be horizontal way. Understood? Then these are the important things in the, we need to draw the graphical representation. Okay, normally then other one is footnote. Okay, in the when we draw the line graph or pie chart, okay, then source of information should be mentioned as the footnote. Okay, source of the information we can insert the as a footnote. Okay, clear? Then this is the session number 3. Okay, then through this session we studied what? Presentation of the categorical data. Okay, now you know what are the categorical data. Okay, then in the first way, then when we need to conduct the survey, okay, then based on the survey we collect the data. Then the first we collect the data we call as the raw data. Okay, then we have lot of numbers, words. Okay, then we cannot easily understand this kind of raw data. Okay, then and we cannot do the further analysis using the raw data. Okay, then therefore the first step is what? Using the raw data, we need to do the summarized data. Okay, then in this session we studied how to summarize it. We can use the tabular format, and we can use the graph, and we can use the diagrammatic way. Okay, in the descriptive statistic part, okay, then we need to do the presentation of the data. Okay, then you know statistic is a process. First one is collecting, second one is organizing, third one is presenting. Okay, that's the third stage. Now we're in third stage. Okay, then we collect the data, we organize it, then we want to present. Then we can use the table, we can use the graph, and we can use the diagram. Okay, then what is the meaning of the table? We use the table, we can represent the numerical data in the rows and columns. That we call as the tabular format. Okay, then we have only one categorical variable. We use the frequency table. Okay, then the first column shows the categories of the variable, others column represent the frequency. We can represent the frequency, percentage value, cumulative percentage value, those things. Okay, then we have the two kind of categorical variable. We use the two-way table. Okay, then we have the three categorical variable. We can move into the three-way table. Okay, now you know how to interpret these kind of contingency table or cross tabulation. Okay, then when we need to summarize the two or more categorical variable, we move into draw the cross tabulation or the contingency table. Okay, then we want to do the visual form of presentation in our statistical data. We use diagrams or the graphs. Okay, then you studied different kinds of diagrams. Okay, then we have only one categorical variable. We use the simple bar diagram. Okay, then we have two or more categorical variable. We can move into the multiple bar diagram or subdivided bar diagram. Okay, then we need to represent the percentage value. We can use the percentage subdivided bar diagram. Okay, then other one is we need to present the data using the graphical way. We use line graphs. Normally we use the line graph, then those values of the variable changes in the over time. Okay, normally we do the conducting the time series analysis, we use the line graph. Okay, then finally we studied important thing. Okay, then when we need to present the data using different way, then must have a title. Okay, then other one is we need to label the two axes. Okay, then we represent the two or more different variables. We need to use different colors or patterns. Okay, then we can insert the footnote. Okay, then footnote normally represent the source of the information. Okay, then those things. Okay, clear? Session 3 is okay. Session number 4, presentation of the quantitative data. Okay, now you know what does mean. The quantitative means what? These data can be measured as numerical. Okay, then we through this chapter 4, okay, then we will discuss how to present the quantitative data. Okay, then chapter 3, we discuss how to present the categorical variables. Okay, then these are the objectives. Okay, introduce the types of quantitative variables. Now you know what are the discrete and what are the continuous variable. Then identify the group and ungrouped approaches of the preparation of frequency distribution. Introduce the concepts of class intervals, class limits, class boundaries, class width, those things. Okay, then those things. Then these are the learning outcomes. Then we move into the raw data. Okay, now you know. Okay, raw data means what? When the data are not arranged in any systematic way, we call it as raw data. Okay, there is no any arrangement. Okay, there is no any arrangement in the systematic way. That we call it as raw data. Okay, in here, example number 1, consider the following marks scored by the 50 students in the mid-semester examination. Okay, then this is the data set. Okay, there is no any arrangement. Okay, then it represents the marks scored by the 50 students. Okay, there is no any systematic arrangement. That we call as what? Raw data. Okay. Then other one is an array. Now you know raw data. Okay, then when we need to do the study, first we identify the what kind of data we need. Based on that, we use the method to collect the data. Then we have the raw data. Okay, then we arrange those raw data in a systematic way, or we can say ascending or descending order. We call as what? Array. Ascending means what? Lowest number to largest number. Descending means highest to lowest. Okay. Then an array means arrangement of raw data in the ascending or descending order. Okay. Then the same example. Okay. Then in here we have the marks scored by the 50 students. This is the raw data set. Okay. Then these data we arrange it ascending order that we call as array. Okay, then identify all the raw data set. Then we arrange it the ascending. First write the lowest value. Then we arrange it lowest to the highest value. Understood? Okay. Then other one is ungrouped data distribution. Okay, then ungrouped data distribution is a table. Okay, then this example is a table. No? Okay, ungrouped data distribution is a table. Then which shows the each value of each variable together with the number it owns. Okay, then now you know there is a raw data set. Then next step we arrange it in the ascending order. Okay, then we summarize the raw data, then their array using the ungrouped data distribution. In here, some numbers are repeated. No? Okay, then in the arrangement, we can see then 30. Then the 5 students obtain the 30 marks. Same value repeat. Okay. Then the 34. Then there are 32. 2 students got the 32. In here, 3 students got the 34. That is a repeated value. Okay, we can summarize it using the ungrouped data distribution. Okay, then ungrouped data distribution is a frequency table. Okay, then first one, then the mark 30. How many got 30? 5 students. Then the 32, then 2 students got the 32. Okay, then first we identify the value of the marks. Then we write down the number of students got that each mark. Understood? That we call as the ungrouped data distribution. Okay, then this value, then the number of students, we called as the frequency value. Okay, then this is the variable in here, marks. That is the quantitative variable. Then this one is the frequency. Okay, understood? That we called as the ungrouped data distribution. A table which shows the each of the value of the variable together with the number of times it occurs. Number of times it occurs means what? Frequency value. Understood? Okay. Then other called as group data distribution, group frequency distribution. In here, we take the value is individual. The first one is 30, in here 32, 34. There is no any groups, no. Okay, then using the group frequency distribution, we have the groups. Okay, then first one represent 60 to 62. Okay, then 63 to 65. There is a range. Okay, then this obtain the marks. Then first one is 5. Frequency value is 5. It means 5 students got the 60 to 62. There is a range. Okay, then these 5 students got marks in between 60 to 62. It may be a 60, it may be a 61, can be. Okay, then next one 63 to 65. Then how many students got? 18 students. 18 students are ranging 63 to 65. Clear? Okay, then some students got 63, some got 64, some got 65. Okay, then there is a group. A tabular arrangement. This is also the tabular format. Now you know the table. Okay. Arrangement of data by classes together with the corresponding class frequency. First, we identify the value of the variable. We group these values. Values of the variables first group. Then we identify the corresponding frequency of each group. Understood? Normally, we denote it as the frequency using the F. Okay. Then other one is in here, sigma F. Sigma is a Greek letter. Okay. Then sigma represent the total. Sigma F means total frequency value. Understood? In here, how many students are there? 100. That's the total value. Okay. Then we need to express the total frequency. We use the sigma F. Okay, then that sigma we called as capital sigma. Okay. Okay. Then we move into the explanation about the group frequency distribution. Okay. In the group frequency distribution is a one kind of table form. Okay. Then in the values of the variable we grouped. Okay, we identified the range. Then these we called as, then first one is 60 to 62. The second one 63 to 65. Okay. Then these we called as class intervals. Okay. How to call this? Class intervals. Okay. Then what is the first class interval in here? 60 to 62. What is the second class interval? 63 to 65. Understood? The next one, then these are the class intervals. Then there are limits now. In the first class intervals, okay, there is a range 60 to 62. There is a 2 points now, 60 and 62. Then these we called as class limits. Understood? Then these we called as class limit. In the first class interval is 60 to 62. It's the first class interval. Then what are the two class limits in the first class interval? 60 and 62. Okay. Then this one 60 is we called as lower class limit. The 62 is upper class limit. Understood? The second class interval is 63 to 65. Then 63 is a lower class limit. 65 is the upper class limit. Understood? Clear? Okay. Then we move into the class boundaries. In here, then these are the class intervals. Then there are class limits, lower and upper one. Okay, then move into the first one, 60 to 62. Then second one starting from 63. There is a gap now. First stop at 62. Second one starting from the 63. There is a gap. Okay, normally we need to draw the histogram. There is no any gap between the bars in the histogram. Okay, then in this class intervals there is a class limit. Then the first class interval, their upper limit is 62. The second class interval lower limit is 63. There is a gap. Okay, then we need to remove these gaps. How to do that? We can do those class limit. We can convert it into the class boundaries. Those are class limits. Then we can convert it into the class boundaries. Okay, how to do that? Then first identify the first class interval in here 60 to 62. Okay, then 62 and there is a 63. What is the gap between 62 and 63? 1. Take the value in between these two values divided by 2. Okay, then or we can take the average between lower one and the upper one. 62 plus 63 divided by 2. What is the value? 62.5. Then the first class interval lower class boundary is what? Lower class, not the lower class. Upper class boundary is what? 62.5. Understood? Then the starting from the second class interval from the 62.5. Okay, then normally in the every class interval there is a class limit. The gap between the two limits, normally two limit means the upper class limit in the first class interval and the lower class limit in the second class interval. Normally their gap is equal to 1. Okay, then easily we can do 0.5 minus lower class limit and 0.5 add to the upper class limit. Okay, then when we convert all the class limit into the class boundaries, okay, there is no any gap between the upper one and the lower class boundaries in the different class intervals. Understood? Then first one is 59.5 to 62.5. Then other one is 62.5 to 65.5. There is no any gap. Okay, understood? Okay. Then other column represent the frequency value. Number of times it occurs. Okay. Then other we called as X. That means class mark. Okay. Class mark means midpoint of the class interval. Okay. Class mark means what? Midpoint of the class interval. Okay. How to calculate the class mark? How to calculate in the class mark? Class mark means midpoint of the class interval. First identify the class interval 60 to 62. We add them two class limits divided by 2. Why? We need to calculate the midpoint now. Okay. Then 60 plus 62 divided by 2. What is the answer? 61. Understood? What is the second class interval class mark? 63 plus 65 divided by 2. Understood? Then next represent the class mark. Okay, then how to calculate the class mark? Class mark is the midpoint of the class interval. We can add the lower one and the upper limit together, then divided by 2. Okay, then class mark we can say it's the midpoint of the class mark. Understood? Then we looking at why we need to take the class mark. What is the reason for that? Okay, when we do the further mathematical analysis, then all the observations belong to the given class interval assumed to coincide with the class mark. There is a range now, 60 to 62. We assume 61 is the class mark. Okay, then we can consider as a 61 is the approximate value in the first class interval. Understood? Then why we need to calculate the class mark? When we need to do the further analysis, okay, then all the observations belong to the given class interval are assumed to coincide with the class mark. Understood? Clear? Okay. Then other one is, then this is the way we can calculate the class mark. Okay, how to do that? Upper class limit of the one class interval plus lower class limit of the next class interval divided by 2. Okay, then the first one is 62 and then another class interval lower limit is 63. Then 62 plus 63 divided by 2, 62 point. Understood? Then next one we can. Okay, understood? Then these we call as the class boundary. Okay, then the smaller number we call as the lower class boundary. Another one we call as the upper class boundary. Okay. Then other we call as class width. Class width we can say, another word we can say size of the class interval. Width or size of the class interval. Okay, then how to calculate the class width or size of the class? Okay, then we can easily calculate the size of the class and the width of the class. It means difference between lower and the upper class boundaries. And now you know class boundaries. Okay, then we take the difference between upper class boundary and the lower class boundary that we call as width of a class or size of the class interval. Okay, in here, then 59.5 and the 62.5 is the first class boundaries in the first class interval. Then take the difference between these two values we call as class width. Okay, understood? Then think if all the class intervals in the frequency distribution have equal width, okay, then we can denote it as the C. Width of a class normally we denote it by using the C letter. Okay, normally we denote it as C. Okay. In here, then the width of a class of each class intervals is 3. Okay, then the width of a class of this particular frequency distribution have a equal width. Okay. Class mark. Now you know what is the class mark. Midpoint of the class interval. Okay, it's obtained by the adding lower class limit and the upper class limit divided by 2. Then we need to calculate the average value, midpoint. Okay, then first one, 60 plus 62 divided by 2. Or we can use the class boundaries. Okay, then when we want to calculate the class mark, we can use class limits and or class boundaries. Okay, then both answers are same. Okay. Understood up to that point? Then this is the way we can present the quantitative data. Okay, then first we identify what are the raw data. Raw data means there is no any arrangement in the systematic way. Okay, there is a data set. There is no any arrangement. Okay, there is no any organized data. Then we call as the raw data. Then using the raw data, we can arrange it ascending or descending order. Okay, then searching the data set. Normally we arrange it the ascending way. Okay, then we can do the descending order, arrange it the descending order. Okay, then lowest to highest. Okay, then when we arrange the data set in the ascending or descending order, we can identify the are there any repeated values. Then when we looking at the raw data set, okay, then the identify the repeated value is not easy, no. Okay, then we cannot easily understand what are the repeated values in here. Okay, but using the array, we can easily understand what values are repeated. Okay, identify then 30, 30, 32, 34, these are the repeated. Okay, then using the array, we can identify what is the lowest value in here. What is the highest value in here? Okay, then what is the most occurrence value in here? Okay, we can do the some kind of analysis using that. Then the raw data set. Okay, raw data set means there is no any systematic way arrangement. Okay. Then ungrouped data distribution, we summarize the array. Okay, then array, there is a ascending order, then we summarized it. Then using the array, we can identify what are the values are repeated terms. Okay, then identify the repeated terms and it represent the value of the variable together with its number of times it occurs. Okay, then 30, there are 5 times 30 is repeated. Then 5 is the frequency value of the 30. 30 is the value of the variable. Then the first row represent the values of the variables. Okay, then second row represent the frequency value. Understood? Okay. Then we move into the group data distribution. Then we have the ungrouped data distribution. Then we summarized further using the group data distribution. Okay. Then we identify the class intervals. Okay. Then we have the data in the array or the ungrouped data distribution. We group together using the class intervals. Okay. Then these group we called as the class intervals. Okay. Then these two are we called as the limits, class limits. Then we can convert it into the class limits to the class boundaries. Okay. Then we can represent the frequency value of each class intervals. Then we can identify the class mark. Okay. Understood? Then when we need to calculate the mean value, standard deviation value, okay, then we need to identify what are the class mark in each class interval. Okay, then the session number 5, we will study summary measures, how to calculate the measures of central tendency, how to calculate the measures of dispersion, those things. Okay, then therefore, then these concepts are very important. What is the class interval? What is the class limits? What are the class boundaries? Okay, then what is the class mark? How to calculate the class mark? Why we need to calculate the class mark? Okay, these are the very important to study the summary measures. Okay. Then we want to calculate the class mark. Why? There is a range. Then we identify the single value to represent these class intervals. The first class interval 60 to 62. Then it represent by the 61. Okay. Then we identify how to calculate the class boundaries and how to identify. Then the class width means what? Size of the class interval. Okay, then take the difference between two class boundaries. Upper class boundaries minus lower class boundary. That represent the width of a class. Okay. In the class mark is the midpoint of the class interval. Those things. Okay. Then we move into the general rules of forming frequency distribution. Think we have raw data set. Okay. Then when we need to construct the group frequency distribution. Okay. Then we looking at how to do that. The first one is then we search in the raw data set. First we identify what is the smallest value and what is the largest value. Understood? Okay, then in here, then your example, we can use the array. No? It's a very easy. No? Then what is the largest value and the smallest value in here? 30 is the smallest value, lowest value. Then 50 is the highest value. That is the first step. Okay. Then using these two values, we can calculate the range. Then highest one is 50, lowest one is 30. It's clear? Okay. Then using these two values, we calculate the range. Range means what? Highest value minus lowest value. In here, highest value is 50. Lowest value is 30. Then what is the range? 20. Okay. Then what is the first step? We search in the raw data set or array. We identify what is the highest value and what is the lowest value. Okay. Then using these two values, we calculate the range. Range means difference between highest value and the lowest value. And in the same example, what is the range? 20. Clear? Okay. Then we move into the second one. Then we identify how many class intervals we need. Okay. In here, how many class intervals are there? 5. Okay. Then we identify how many class intervals we need. Okay. Normally we use the 5 to 5, 7 or 12. Okay. The maximum number of class intervals normally we include 12. Okay. Then we take the highest then higher number of class intervals. Then the group frequency distribution may be lengthier. Okay. Then we decide how many class intervals we need. Okay. Then think we need the 6 class intervals. 5 class intervals. Think 5. Okay. Then it is your assumption. Then we assume how many class intervals we need. We assume 5. Now you have the range. No. What is the range value? In same example, 20. Then now you know range in this data set 20. Then we need 5 class intervals. Okay. Then we move into the construct the frequency distribution. We identify we need to write the 2 class limit according to the width of a class. Okay, then third step is we calculate the width of a class, size of the class intervals. Okay, how to calculate the size of the class interval? Then now you know range and you know how many class intervals we need. Okay, then range divided by the number of class intervals we called as the size of the class interval. How to calculate now? 20 divided by 5. Understood? Then what is the size of the class interval? Okay, understood? Then now have the idea about then smallest value is 30, highest number is the 50, width of a class or size of the class is 4. Now you can construct the group frequency distribution. The firstly, we identify the highest and the lowest value. According to that, you can calculate the range. Then you identify how many class intervals do we need. Then we calculate the size of the class interval. Okay, then based on the size of the class interval, we can write the each class intervals. Okay, then starting from which number? 30. Then starting from 30. That is the lower class limit in the first class interval. Then what is the upper class limit in the first class interval? Think and tell. Size of the class is 4. No? Okay. Then first class interval starting from 30. That is the lower class limit in the first class interval. Then what is the upper class limit in the first class interval? Hmm? 33. Why? The size of the class is 4. No? Then 30, 31, 32, 33. Okay. Then what is the two limits in the first class interval? 30 to 33. Okay. Then next class interval starting from 34. 34 to 37. Understood? Then the third one, 38 to 41. That is the way we can write the class limits of the each class interval. Okay. In the group frequency distribution, then first column is now okay. We can write the class intervals. Okay. Then we need to frequency value. Okay. Then how to calculate the frequency of each class interval? Using what? You know. Using what you can calculate the frequency of each class intervals. Then think you have the raw data set. We cannot easily understand and identify the repeated values. No? Raw data set. There's no any systematic arrangement. Okay, then how to take the frequency of each class intervals? Using what? Tally marks. Remember? Tally marks. Then we write the dashes in the 5. Then 4. Then fifth one is we cut. Okay, then these are we called as the this way. Normally we draw this way. No? First one, second one, third one, the fourth one. Then we have the fifth, we cut it. Then these we called as the tally marks. Understood? Then using the tally marks, we can identify the frequency of each class interval. Understood? Clear? Okay, now you know how to construct the group frequency distribution. We search in the raw data set. First identify what is the highest one and the lowest one. Using these two values, we calculate the range. Then we identify how many class intervals do we need. Okay. Then range divided by number of class intervals, we known as size of the class. Okay. Then based on this value, we can write the class limits in the each class intervals. Okay. Then we write the class limits in the class interval. Then we need to calculate the frequency. Okay. Then how to calculate the frequency value? How to get the frequency value? Using the tally marks. Okay. Then there is an example. Make a frequency distribution with 7 class intervals from the following data. Okay, that is the raw data set. What is the first step? No need to do the arrangement. That is not a compulsory. No. We can use the raw data. Okay. Then what's the first step? Identify the lowest value and the highest value. In here, what is the lowest and the highest value? 30, 30 and the 19. Then the lowest is the 30. Highest value is the 99. Okay. Then what is the next step? Now we take the value, two values, highest one and the lowest one. The next step is we calculate the range. How to calculate the range? Highest value minus lowest value. What is the range? 69. Okay, then what is the next step? Assuming the number of class intervals. In here, this question is given that make a frequency distribution with 7 class intervals. Okay, then what is the number of class intervals in here? 7. Okay, then we can calculate now size of the class interval or width of a class. Okay, how to calculate the width of a class? Range divided by number of class intervals. Range is 69. Then the number of class intervals is 7. Then 69 divided by 7. Then what is the answer? .8 something. No? Okay, then we can take the approximately. What is the answer? Take. Normally we take the whole number. Okay, we do not take the decimal values. Then what is the size of the class? 10. Okay, now we can start write the class limit. Okay, starting from what? 30. Okay, in here, then the size of the class is 10. Then what is the upper class limit in the first class interval? 39. Okay, then the 40 to 49. Okay, then 50 to 59. 60 to 69. This way we can write all the class intervals. Okay. Okay. Then 99 is the endpoint. Okay. Then these are class intervals. Okay, then first step is okay. Then we need to calculate the these we called as the class intervals. Okay, then we need to the frequency value. We denoted as F. Then how to calculate the frequency value? Using the tally marks. Or you can take the count. Okay. Then hurry up, do that one and tell me the frequency value of each class intervals. What is the frequency? Do that one and tell me. Correct? Those values are correct. First, 30 to 39. What is the frequency? 3. Okay, no? The second one is 40 to 49. 6. Okay. Then the 50 to 59. 6. Okay. Then the 60 to 69. 6. 7. 7. Okay. Then 70 to 79. 5. Then 80 to 89. 8. 8. Then 90 to 99. 1. 5. Yeah, no? Then this is the group frequency distribution. Okay, clear? Okay. Then we move into the histogram. You know the histogram. Then we need to present in the frequency distribution of the continuous series. Okay, then what is the way? We can use the histogram. Okay, histogram. Understood? Then the histogram is the graphical representation of the frequency distribution. Okay, now you know how to develop the group frequency distribution. Then this is the way we can represent in the visual way using the group frequency distribution. Histogram. Okay, in the horizontal axis, and there are two axes. Okay, In the horizontal axis represent what? Horizontal axis represent the class intervals. Okay. In the vertical axis represent the frequency value. Frequency, no? In the group frequency distribution, there are two columns now. First column represent the class interval, second column represent the relevant frequency. Okay, then horizontal axis represent the class intervals, vertical axis represent the frequency. Understood? Okay, when we need to draw the histogram, okay, then normally we construct the group frequency distribution. There are class limits, no? Okay, in the class limit, there is a gap. Okay, then using the class limits, we cannot draw the histogram. Okay, then when we need to draw the histogram, we use class boundaries. Okay, using the class boundaries, there is no any gap. No. Okay, then when we need to draw the histogram, we use class boundaries. Okay, then the class boundaries represent the horizontal axis. Vertical axis represent the frequency value. Understood? Okay. Then this is the example. Okay, then think. Then our example in this class, this group frequency distribution, then first point is starting from 30. No? Okay, then starting from 30. Then 0 to 30, there is a range is 30. Okay, then 30 to 39 is the class limits. No? Then first step, we converted all those class limits to class boundaries. Okay, then what is the first class boundary? 29.5 to 39.5. Okay. First we can write 29.5 to 39.5. Okay. Then next one is 39.5 to 49.5. Okay. Then these are the class boundaries. Then there is no any gap. Okay. Then the first one not starting from the 0. No. Starting from 29.5. Normally we draw the horizontal axis from 0. Then 0 to 29.5, there is a gap. The next one, mark it 39.5. Their gap is 10. But 0 to 29.5, their gap is 29.5. Okay, then the size of the bars are not equal now. Okay, then we draw the horizontal axis. Then normally starting from 0. Okay, the next point we starting from 29.5. The next one is 39.5. Okay, then there is a large gap. Then we use in what? We draw the false line. Understood? At that situation, we draw the false line. Clear? Then in the group frequency distribution, then first class interval starting from 0, there's no. Okay, then think some class intervals may be, then we take this example. Then the class limits, class boundaries are, then the first one is starting from then 5 to 10. Then 10 to 15. There is no gap now. Then we can draw directly. Okay. Then this one starting from 5. Second one is 10. Then 15. Those when. Then 0 to 5 and 5 to 10. They are same gap now. Okay. Then at that situation, we do not need to draw the false line. Okay. Understood? Then first we looking at the range between two gaps, two class boundaries. Okay, then the starting point, there is a lengthier gap, then we use false line to summarize. Understood? Then these are the very important things. Then we can draw the histogram. Okay, then using the SPSS software, we can directly take the histogram. Okay, then we insert the data, insert the quantitative data, then we take the right path to take the histogram. Okay, then first we select the data, then first we go to the descriptive and then analysis, then we move into the descriptive analysis, we can take the histogram. Okay, then you need to do the identify which kind of data we can get the histogram. That is the important thing. Okay, normally we can take the histogram using the quantitative data. Understood? It's clear? And the other one is normally using the histogram in the continuous variables. Why? In the continuous variable, there is a gradation between the two values of the measurements. Okay, then that's the reason. Now clear? Is the session number 4. Okay, then through this chapter 4, we studied how to present in the quantitative data. Okay, then session 3, we studied how to present the categorical data. Okay, in the categorical variables, we can represent using the table format, graph, and the diagram. Using the when we need to present the quantitative data, we use the frequency distribution. Okay, visual formation is the what? Histogram. Okay, clear?